Good morning, ladies and gentlemen. Christmas Carter is here.
Hi, Mr. Main.
Good morning, Avery. Good morning, Christmas Carter. Good morning, Button. I'm probably going to call you Christmas Carter from now on, Carter. Oh, I love it. Classic. Ethan. Well, if you don't like it, tell me and I won't call you it, but as you know, I love nicknames, so. Okay. Haley B is here. Brando is here. Lily is here. Isabella is here. Courtney Hare is here. Sawyer is here. Hey, Sawyer, you need to go in and you need to make sure that you change your name to first and last, okay? Not right now, just today at some point. No, why does it keep doing that? My theory keeps turning on. I don't understand. Oh, okay, no problem, Sawyer. That was Gabby Campney. That was here. Aaliyah is here. Okay, so I'm putting. Okay, that's not a big deal. So I am putting I'm putting grades in the grade book today. So this afternoon at 1 o'clock, I am having a meeting. Not like you don't need I'm just having a meeting in case you have questions about any of those grades that I put in. So, Aaliyah, I don't have a couple of your grades from Miss Albert, so some of them you're going to be exempt from just because I don't have them from you. I don't know how to get them. So you're going to have some exempts in there. Cool. Let me get started with today. So if you look at today, we're literally doing one slide, like there's one new slide of work, but it's going to take the time. So let's get started with today. Let me share my screen. Here we go. Let me close that out. Let me open this up and let's take a look at slide number 2. So our goal for the day is we're keeping equations balanced. I want you to take 1 minute right now to tell me one thing that you notice, at least one thing that you notice, and one thing that you wonder about these socks here. Take 1 minute starting now. Boom. TS just emailed me. I think that was about his internet. And chat. We're taking another 27 to write down one thing that we notice, one thing that we wonder. Okay. Here we go. Here we go. Okay, so yes, Sawyer remembers doing this unit last year. And you know what's funny? Last class I had his Edgar, you guys know Edgar. Edgar was like, "Oh my god, we literally did this last year." And I said to him, "I know, that's crazy. But it's gonna take a different turn than the way we went about it last year though. So don't feel like we're doing the same thing over and over and over again. But yes. So Avery gave me a notice in the chat. Notice is that the lower sock is stretched out more. I wonder why. That's a good thing to notice. I'm going to copy that guy. And we're going to come in here. I'm going to paste in Avery's suggestion here. And then I'm going to bring this wonder over here. I like this. Why socks? I know, right? I wonder that as well. Why socks? What I'm thinking is like they're trying to do something like a hanger to like keep balance. So I think that's why we're dealing with socks. So let's see. Oh, did this in 6th grade. It's crazy. So can I have, let's see. Can I have Kaylee B, can you unmute and can you tell me either one thing that you noticed or one thing that you wondered?
I noticed how like one of the hangers that has socks is like straight, and then the other one is like diagonal.
Okay, so one pair is straight, one is diagonal. Oh my goodness, no, I didn't spell it right. I thought I had it. Okay, good. That's a good thing to notice. Alyssa Button, do you have anything that you wondered about or noticed about? I think pizza just wouldn't work here, Avery. Courtney said that 2 different pairs of socks that have different colors. Very good. One thing that you noticed, different colors. Boom. Let's try to spell things correctly today, Mr. Main. Different colors of those socks. Good. That's another good thing. Sawyer, what did you notice? Go ahead, or wonder.
I noticed that something heavy looks like it's inside one of the blue socks because it's making it diagonal, while the other socks might have something inside them, but they're both the same object, so it's making it even.
Okay. I like that, Sawyer. So Sawyer said that it looks like aesthetically that the blue sock looks like it has something in it, and that something that's in it is making it so that it's heavier. He said that the Red Sox might have something in them, but whatever's in them is the same weight in each one. Good thing. That's a really good thing to notice there, Sawyer. Christmas Carter said, I wonder why would you even put stuff in socks? Okay, that's a good question. And I honestly think you answered your own question. Yes, you can go to the bathroom because he also added on here, unless there's like those smell removers. And listen, when I was in high school and I ran, I used those all the time. So I feel that way about it. So yes, that is a good ask then answer type situation. Carter, you can go to the bathroom. I feel like I already said that, but yes, you can. We don't, let me see. Was Jaden here this morning, guys? Oh wait, I think he emailed me saying there's something up with the internet. His internet is getting, yes, perfect. Okay, so his internet was getting some work done, so maybe there's that. So the one thing that I want us to take away from this guy here, I understand it's fun talking about socks. I personally love socks. They're so comfortable and make my feet warm. Let's come away. Let's try to grab these takeaways from this activity here. So if we look at this red pair of socks here, they are balanced. They weigh the same amount. Sawyer said that they could have something in them, but if they have something in them, it's the same weight in each sock. Okay. Second thing is when we have an unbalanced piece here, an unbalanced hanger, the takeaway is that one of the socks weighs more than the other. That's all that we're trying to take away from this guy here is that when we have balanced socks, they weigh the same amount. When we have unbalanced objects, one of them weighs more. And this one that's tipping down is the one that weighs more. Okay, so let's take a look at our learning target for today. Okay, so I can add or remove blocks from a hanger to keep the hanger balanced. That's number 1. Number 2, I can represent balanced hangers with equations. So there are 2 pieces to this activity here. One is adding and removing blocks to keep it balanced. Another is representing balanced hangers with equations. Okay. So let's take a look at our activity for today. we have this hanger right here. This picture represents a hanger that is balanced because the weight on each side is the same. When we're looking at a hanger diagram, we can tell that it's balanced because this guy on top here is flat. If we have a top if we have a hanger where the top is flat like that, that means it is balanced. If you have it one where it's tipped in either way, that means that hanger is unbalanced and that weight, the one that's down, weighs more, has more value than the one that's going up. Does that make sense, you guys? I want to make sure that that makes sense first.
Yes, that makes sense.
Thank you, Olivia. I love positive reinforcement. So I'm going to say it one more time. So if you have a hanger and it's flat on top, that means it's balanced. If you have one that's tipped, that means it is unbalanced. One side weighs more than the other. Okay, so this guy here is flat on top, so that means it's balanced. So now, here is what Elena's going to do with this hanger. She's going to take 2 triangles off of the left side and 3 triangles off of the right side. So what I'm going to do is I'm going to take this X and I'm going to X out 2 of these on the left side and 3 of these triangles on the right side. I want you to take 1 minute right now to, on your slideshow, X out your triangles on there as well. So I want you to take 1 minute to X out your triangles as well. There we go. It's a little bit bigger. Okay, we're taking another 30 to X out your triangles on each side of your hanger. Perfect. Thank you, Avery. Wonderful. Another 15. Once you do that, you can come back to the Zoom and just wait for everybody else to join back. Okay. Okay, so we just X'd out 2 on the left and 3 on the right. My question to you is, will the hanger still be balanced or will it tip to one side? I want you to take 30 seconds right now to decide, is it going to be balanced or is it going to tip to one side? I want you to take 30 seconds right now and then let me know in the chat, will it tip or be balanced? Balanced or tipped? Okay. Some friends put answers in the chat. Looks good to me. Thank you, Aaliyah. Thank you, Sawyer. Thank you, Bridget. Let's get some more answers. What do we think? Is it going to tip or is it going to be balanced? Okay, some people are saying it's going to be balanced. Let me see if adding one more piece of information to this will help you. Every single triangle here weighs the same amount. So if you're taking 2 triangles away from one side and they weigh 1 gram each, you're taking away 2. If you're taking the 3 triangles on the left side, you're taking away 3. So now I want you to think for another 30 seconds. If I take away different amounts on each side, will it still be balanced? Nice job, Avery. All the squares weigh the same amount as well. So like, for example, if they weighed 2, they'd all weigh 2. Okay, we're going to take another 3 more seconds. Okay, so here we go. We have to decide. We're taking away different amounts from each side. And if, for example, they each weighed 1, we would be taking away 2 from one side and 3 from the other side. Does taking away different amounts keep it balanced? Olivia, what do you think?
I think it's still going to be balanced.
Okay, so Olivia thinks it's still going to be balanced. We're taking away. Bridget just said in the chat that she doesn't necessarily agree. Bridget, what are you thinking? What's your thinking behind this?
I think that it's not going to be balanced because the square and the triangle are like different grams, and you're taking away different triangles from each side, so I don't think it's going to be balanced.
Okay, very good. Thank you, Bridget. That was a very good explanation there, my friend. So because Bridget is basically saying, because we're taking away different amounts from each side, we're not going to be balanced anymore. If I have let me grab one thing. If I have a cup, I have 2 cups here. And I start off with 6 marshmallows in each cup of hot chocolate. But then I am a bad kid. And this is Bridget's cup, this is my cup. I take away 3 from Bridget's cup, and I take only 2 away from my cup. Am I taking away the same amount?
No.
Exactly, Sawyer. I'm not taking the same amount away. So I'm not going to be balanced anymore. We're not going to both have the same amount of marshmallows anymore. This isn't a trick question. I know you guys might think it's a trick question, but it's not. You want to think logically. If you take different amounts away from each side, they're not going to be balanced anymore. If I take 3 marshmallows away from Bridget and only 2 away from me, I'm going to have more now, right? Does that make sense, guys? For my friends that were thinking it was still going to be balanced, do we see now why it's not going to be balanced? Okay, good. Thank you, Olivia. Thank you, Avery. Thank you, Courtney. So when you want to keep something balanced, you have to take away the same amount from each side. So if I wanted to keep this balanced here, if I was to, for example, look at this guy again, and I were to take 2 away from my left side, how many would I then have to take away from my right side for it to stay balanced? We're going to start again. Nice job, Bridget. How many, if I take away my 2 on my left side and I want to keep it balanced, how many do I have to take away from the right side? I have 1 person that put it in the chat. How many would I have to take away from the right side to keep it balanced? Not necessarily, Avery. Very good, Faith. Very good. Exactly. But Sawyer, how many? Exactly. You said 1 or 2, but I want to keep it balanced. So if I take 2 away from my left side, I have to take away how many from my right side? If I want to keep it balanced and I take 2 away from my left side, this is not a trick question. I have to take away 2 from the right side as well, because all of my triangles weigh the same amount. And if I want to take the same amount away on each side, I take 2 away from my left side, I have to take 2 away from my right side as well. Okay? So if I wanted to keep it balanced, I would have to, Jonah is here. I would have to take away 2 from the right side as well. Not a trick question, I promise. It is just a little bit, I know it is a little bit challenging though. okay? So in order to keep an equation or a hanger balanced, we have to take away the same amount from each side. Good. What if I was to, on the right side, do this? What would I have to do on the left side? If I were to X out one of my squares, what would I have to do on my right side? The same thing, very good. Avery was really specific. She said that we'd have to get rid of one on the right side, the left side as well. Good. So I'm going to take my X here and I'm going to X out one of those squares as well. Because when I do something to one side, I have to do the same thing on the other to keep it balanced. And that is our goal for this unit, is to always keep hangers / equations balanced. And the way that we do that is by taking away the same amount on each side or doing the same operation on each side. So if we were to only take off 2 on one side and 3 on the other, it would be tipped. It would be tipped because it's no longer balanced. We took more away on one side than the other. We didn't take the same amount away on each side. We didn't take the same amount away on each side. Okay, so basically when it's asking us, did it maintain, did it stay balanced or did it get tipped? We're saying it got tipped because we didn't take the same amount away on each side. We took 2 away on one side and 3 away on the other. Not a big deal, Gabby Campany. If you want to go back and watch the recording later, you can do that for the part that you missed, okay? So now, we're using these pieces that we have left because we got rid of the like pieces on each side. I got rid of a square on the left, so I can get rid of a square on the right, and it's still going to be equivalent. I got rid of 2 triangles on the left, so I got rid of 2 triangles on the right. Now, let's answer a question. If a triangle weighs 1 gram, how much does a square weigh? Okay, so this next piece I'm going to do on my slides. You don't need to do it on your slides because I didn't give you, nice job, Alyssa Button, I didn't give you text boxes here. So if I were to come onto here and I were to label this triangle, this would be labeled as 1 because we said it was labeled, it weighs 1 gram. So I would label all of my triangles as 1 because that's how much they weigh. Okay, Control copy, Control V. Okay, and my squares, if I don't know, nice job, Lily. If I don't know what my squares are worth, how can I find, what can I label these squares then? If I don't know what they're worth and they're an unknown variable, what can I label these squares with what? Nice job, Avery. What do we think we can label this with? Very good. Nice job, Bridget. Let's take a look at that. We could label it as the variable x. Very good. So because we don't know what it is, we're going to call it x. Okay? So I'm going to label my other, Control copy, Control V. I'm going to label my other square as an x. So now in this box right here, we're going to write an equation that matches this story. So if I'm looking at this hanger diagram, what do I have on my left side here? What do I have on my left side? 2 what? Very good. Very good, Bridget. Very good, Avery. What do I have on my left side here? Not on the whole thing, just on the left side. Okay, so on the left side, I canceled some things out. So I'm only left with, Olivia, yes, very good. The square that is equal to x, very good. So we have these 2 squares here, which means we have 2x. Okay, because we have 2 x's. And we're going to say that it's equal to this amount on the other side. How much do we have on the other side? The right side. Very good, Olivia. Very good, Avery. Very good, Gabby Campany. Very good, Bridget. How much do I have on my left or my right side here? Nice job. Very good. Well, we canceled these guys out, so we're just looking at the pieces that are left. So we have a 2x on the right, the left side. On the right side, it's going to be equal to, so the left side is here, is equal to what's on the right side, which is 3. Okay, so the equation that we're going to write, nice job here, Sawyer, Alyssa, and Faith and Lily. Very good. Very good. That's a good way to write it, Lily. We have 2x is equal to 3. So if I want to figure out how much 1x is or 1 square is, what do I have to do to each side to get the x by itself? Very good, Avery. What do we think, guys? What are we going to have to do to each side? Very good, Bridget. Thank you, Olivia and Faith. Yes, girls. Nice job, Bridget. That's a good final answer. We're going to have to divide, and we're going to have to divide each side by 2. To get that x out of there, we have to divide by 2 on each side. So if we come in this box, we hit our little enter, we do our 2's underneath, we underline them, and we're going to hit enter, because when we do this, we're left with just an x is equal to what? You can write it one of 2 ways. Very good, Bridget. Very good, Avery. Yes. Very good, Bridget. So it's going to be equal to, let Sawyer back in. It's going to be equal to 3 over 2, right? Oh, I didn't click in the box, sorry. 3 halves, right? Or if you were to do it in your calculator, you would get 1.5. Oh no, we just lost somebody again. I think Sawyer Sawyer didn't fall out. So x is going to be equal to 1.5. So how much does 1 square weigh? That's okay, Sawyer. How much does one square weigh?
1.5.
Exactly, Sawyer. Very good. It weighs 1.5 grams. Look at that. Nice job. So I just have one final question before we're done for today. I have this equation right here. I have x plus 4 is equal to 18. Okay. How do I get my x by itself? What do I have to do? How much? Very good, Faith, Olivia, Bridget. Very good, Avery. Very good, Olivia. We're going to subtract 4 from each side. We're going to subtract 4. Then what do I have to do to my right side? I also have to subtract 4 on the right side as well. And I know that we know this, but I just wanted to make sure that you guys see this. So when we are doing this here, when we are simplifying an equation, we're solving for x, we do the same thing to one side that we do to the other. So the same thing we did here when we were simplifying these hanger diagrams. When we got rid of something on one side, we have to get rid of the same amount on the other side to keep it balanced. When we're keeping it balanced on this hanger diagram, you're doing the same thing in this equation right here. You're keeping it balanced. When you take something away or do something to one side, you have to do the same exact thing to the other side to keep it balanced. Or I'm going to keep saying this phrase, to maintain equity, to keep them equal. is what maintain equity means. Okay. So today, what did we do in class today? We did two things, really. We looked at hanger diagrams. We talked about how to keep or maintain equity by doing the same thing to one side as you do to the other side. That's number one. Number two, we actually created equations for these different hanger diagrams. This afternoon, with help from the video, what you're going to be doing is you're going to be doing the same thing again. You're going to be labeling some values that you know, finding the weights of the missing pieces, and writing an equation for two hanger diagrams. The videos for these are going to be super duper important because I don't want you to get too, I want you to understand what we're doing. So I want you to watch the video. To close off for today, I need every single person to come to this cohort 3 and click on that link and open up the Edpuzzle video. I want to make sure that it plays for you. So every single person, click on the link on slide number 5 to make sure that the video works for you. Let me know in the chat if yours does not work for you. Perfect. Alyssa Buttons works. Perfect. If it does work, if you want to like put in the chat, like works. Thank you, Olivia. Faith's works. Yes. Courtney's and Bridget's works. Perfect. The thing is like, I don't want people to not be able to do the afternoon work because they can't get to the video, because I can I have like a separate link other than Edpuzzle that I can share with you if it doesn't work. So if you discover when you go back in later on that your video is not working, send me an email and I have a link that is like a YouTube link. So awesome on that. Okay, so if later on when you try to open it, if it's still having trouble loading, let me know and I can send you the YouTube link, okay? Perfect. Okay, so I'm going to stop my share and you guys are free to head out. If you have questions for me, you can stay behind. If you want to say goodbye,